left last time, in the sense that we have to see how we could see invariance. We have to see invariance of the additive operator. Last time, if you remember, we had arrived at a relationship. For example, for a one-particle basis, जो हमारा additive operator है, in that sense, we arrived at this relation. AI dagger is equal to sigma T B dagger P B key. Or if it's invariant under unity transformation, sigma of AI dagger is equal to sigma of K BI dagger. So it's basically how we can write annihilation operators on the one basis with the annihilation operator on the other basis, or creation operators on one side with the creation operators on the dual basis in the given Fox space. How we can represent them. Now the exercise, if you see book exercise 20.1 says verify the invariance of additive operator. Okay, you see invariance of book in that sense. So invariance दिखाने के लिए what we are going to see is basically so using the principles of symmetry, unitary symmetry. Unitary symmetry, if you remember, we had AI, जो हमारे पास था AI was sigma AI ऐसे. So we could write AI to we could relate with this some inner product or some unity transformation. This is the AI dagger को भी हम लिख सकते थे as like this L2KI. So we could write relate A dagger with this or with this via some these two unitary transformations. अब हमारे पास ये है कि at the end we arrived at this sort of relation which is additive. अब ये कह रहा है कि we should verify invariance of the additive operator. That's the thing we have to see. So we expect we Ni जो इसका हम ऑक्यूपेशन नंबर भी डिनोट करेंगे, n को हम ऐसे डिनोट करते हैं. N is basically Ni is basically Nk for one particle basis. One particle basis means we had one particle basis, two particle basis, and so N1, one particle basis is particle of the same kind. So इसका जो ये है for one particle basis, you can also write it as Ni as in terms of creation and annihilation operators, where we can write this x and y will be some constants, I will be some identity. So basically n can be written as this AI dagger. Like that जो n है जो हमारे पास ये है, it acts on the this vacuum state. It will do 0 or y is equal to 0 for your vacuum state here. For any other state, n operating on this side will give psi I for one particle state. So means if you remember some creation operators or annihilation operators, they used act on some basis state. For vacuum state, it will be 0 or whether it's creation operator acting on vacuum state or annihilation operator acting on vacuum state. But any other creation operator operating on any state, it will have उसका corresponding, it will give one particle state, या अगर फिर करेंगे या two particle जो भी. So for this acting on this, it will give this side. Where Ni can be written as AI dagger. So if the basis vectors are this हमारी जो basis vector है, just do if it's written by हमारे पास basis vector है कैसे n1 n2 so on and So this can be one particle states, two particle states. So it's an infinite dimensional state. So we can choose one particle states. इसकी एक subspace बन सकती है. या two particle state दूसरी subspace बन सकती है. Three particle states. So one particle space को हम लेंगे. It's a subspace of that entire space in that sense. So taking that thing into consideration, what we are going to see is basically. So and by defining relations, जो हमारे पास दो relations to remember. Either a creation operator will act on this n particle states. It will only take n1 पे act करेगा, others will not take. So it will be proportional to n1, n2, so on, and ni minus 1, ni plus 1, ni plus 1. In the same way, annihilation operator acting on one particle state, n. Ni plus 1 will be ni minus 1, ni minus 1, ni plus 1. You can have these creation operators or annihilation operators. They are acting on this one particular state, and that this is the whatever that means. अब ये है कि following conditions ought to be met doing this algebra. These conditions ought to be met. कौन सी conditions हैं? So ni ai k minus ai n, or this we did from our previous class. So at the end we arrived at this relation. ai dagger minus a dagger a is equal to n times, or it's equal to I. So in the same way, in terms of ni, so if you just crisscross it, you can write it like this. Ni minus ai is equal to. So now you can write it in terms of creation operators. You can write it annihilation operators. You can write it in terms of creation operators. A dagger minus a dagger k and k is 0 for I not equal to k. Or हमारे पास further, if you want to write them, you can see ni ai minus ai ni is equal to minus ai and ni ai dagger minus a dagger and ni is equal to e dagger. So commutation relations have been proved. Commutation relations. If you see commutation relations, हमारे पास थी ये one. ai dagger, ai aj dagger minus aj ai dagger is equal to 0, and anti-commutation relation हमारे पास थी plus aj ai is equal to 0. So you can see, so we are going, this is the operators acting on this state. So these are non-particle states. For creation operators acting on one particle state, annihilation operators acting on one particle state. This is a creation operators, two creation operators, and two annihilation operators are related with some basis state. And these are the commutation relations, and this is the occupation number. So using all of them together, we have to basically arrive at something. हमको we arrived at something called this. We have to arrive to this. So up in our previous class, what we did, we arrived at this relation. Employee operator to deduce essay 1 plus minus of n of a k is equal to 0. Now we have got number operator here, and you can see this way. अब हमारे पास from 18 to 20 equation 18 to 20 this is 18 20 so we can use these जो हमारे पास कम्यूटेटर्स है एक हमारे पास ये कम्यूटेटर है ये हमारे पास एंटी कम्यूटेटर है these two commutator and anti-two commutator we have to see how we can see for particular values of mu हमारे पास है mu can be +1 or mu can be -1 so plus and -1 जो हमारे पास आएगा it will give us how we can write both Einstein statistics or Fermi-Dirac statistics to be precise enough. तो बोस आइंस्टाइन के स्टैट्स केस में बोस आइंस्टाइन केस is AL dagger minus AL dagger AK dagger AKAL minus AL AK is 0 or the third AKAL minus AL dagger AK is delta AL is I. So if you remember, creation operators. So if here you can see this is dagger, 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 dagger. This is one of them is dagger, one of them is dagger, but both of them are the same. In the third one, A is no dagger. So odd sense. A creation, A annihilation, A creation, annihilation. In those cases, both of them are creation operators, both of them are annihilation operators. So for creation annihilation, this commutator na yahan par gaya hai, just like my chronicle delta. This you have to remember. In the same way, for Fermi-Dirac statistics, we can have now here it's a commutator. We can have now anti-commutator. It's this like this. AL dagger, AK dagger is 0. AK AL plus AL AK is 0. Or AL AK dagger plus AL dagger AK is 1. Here. So characteristic we say that each of one or the other particle of these one particle states belongs to one or another thing. Is equals two kinds of statistics. Two kinds of statistics. They are
Sir, student करू क्या सर तुमसे वेट करा
So we could see these are two kinds of statistics which are there. For fermions, it's called Fermi-Dirac, and for bosons, it's called Bose-Einstein statistics. So, when spatial rotation will be lying, once you study quantum field theory, you can have the idea of spatial rotation also can be found. And you can have a particular description in quantum field theory. हम कैसे इस चीज को करते हैं. And from this, a good consequences is AK dagger जो हमारे पास आएगा. For example, AKAL. So if K is equal to L, this means twice AKA dagger is equal to this 0. So from this, you can have a validity of what Pauli's exclusion principle. And no two particles can be in the same state. Yeah, no two electrons. You have earlier classes when you study that you cannot have the same quantum number. The other thing is that we can also show through the feasibility of the suggested phase transitions. We have another exercise 21.4 say to prove that from the computation relations AI use the operator Ni is equal to AI has a, has as all negative, no negative integers in case of Bose-Einstein statistics, but only 0 and 1 for. So for all non-negative values, it has values non-negative for Bose-Einstein statistics. और फर्क नहीं दे रहा कि इस वैल्यू इसका 0 and 1 आएगा. This is next. You can see through exercise. So if you want to summarize our today's thing, is that we can summarize we can summarize our the creation and summarize creation and annihilation operators. We should omit all identifying subscripts. हम subscripts पे ध्यान ज़्यादा नहीं डालेंगे. What we are going to see, we see typical operators like AI dagger. It's application of these eigenstates. Eigenstates में कहाँ से आएंगे? It may be N1, N2, N3, or N. Since we are only interested in one particle states, the N1 normally आएगा, or the particles of the same kind. Such that the number of operators here, which may be defined like this, acting on this state will give you this N. So A dagger A is equal to N. A dagger A is equal to N. So that relation can be retrieved from this. And for Bose-Einstein case, A of acting on this should be equal to. So root कैसे आता है? Let's see it. It's a non. You can see it comes like this. Or for this creation operator, it acts on it will push state push n to n plus 1. Plus 1 acting 1. And for Fourier, A acting on so vacuum state equal to state act will be vacuum. Now creation operator acting on vacuum will give you this thing or the alpha 1 and A acting on one particle state will give you this. For Bose-Einstein statistics, the structure of the phase is isomorphic to that of harmonic oscillator. है ना जिस तरह आप harmonic oscillator लेते हैं ना ground state पे as a harmonic linear harmonic oscillator. जब हम solution of Schrodinger equation लेते हैं जो eigenstates होते हैं ऐसे we take it first state ground state हो गया n plus 1 by 2 h omega. फिर next state कंटिन्यूस स्टेट्स आते हैं जो एनर्जी आइगन स्टेट पे जो ऑपरेटर एक्ट करेगा दे विल गिव डिफरेंट वैल्यूज आइगन वैल्यूज फॉर n इज इक्वल टू 0 1 1 by 2 1 by 3 बट सिंस वहां पर रिलेशन है इन टर्म्स ऑफ n plus 1 by half so Hamiltonian will be given by h omega n plus 1 by 2 half. We can see these different one particle states, two particle states, three particle states, and we are concentrating only on n is equal to 1. So how we can have Bose statistics and fermion statistics with that how इनका जो commutators हैं or anti-commutators हैं, and for the same commutators it's zero. For if there's a creation annihilation operator, we have this Kronecker delta function यहाँ पर ये है. Otherwise the relation has a symmetry and we know it comes from the previous one. And only thing in the class one, how we say define this number operator as a creation or elimination operator को मिला के. And it's how it acts on the states and how it acts on parameters case. So this is today's class. Will you stop? Anything you have to ask? Okay.